Welcome back to the Global Research Forum, Day 2, 24th August. I hope all of you have had a good lunch after a very enriching keynote session number 3 by Professor Noisher Contractor. So now we are proceeding with our next segment of the program, which is basically on theme number 3 on the development and sustainability. So I'll be your moderator for today. My name is Elmie. I'm from the Department of Communications and New Media at the Faculty of Arts and Social Sciences. We have with us here 3 very notable experts in their field to talk about 3 very largely separate topics, but all focused on development and sustainability. So I'm just going to introduce the 3 speakers briefly. And for the 3 speakers and for participants in this theme, just for some administrative matters, the speakers will speak for 10 to 15 minutes and present their talk for 10 to 15 minutes. Following which, we'll have a Q&A section. So please do take notes or take any questions, or you can actually, or otherwise you can actually input your questions in the Q&A function in the Zoom room, right? So basically you can either put them in or keep your questions till the end, where I will ask participants for their questions, and you can ask any of the 3 speakers their question. So without further ado, let me just introduce the 3 speakers. We have with us here Professor Lorenz Goette from the Department of Economics in the National University of Singapore. He will be discussing his topic or his paper on the role of attention in resource conservation and evidence from the field experiments. Following which, we'll have Professor Alberto Salvo. He'll be talking about, from the Department of Economics and Global Asia Institute in NUS. He'll be presenting on household responses to environmental degradation. And last but definitely not least, we have Professor Feng Qiushi from the Department of Sociology and the Center for Family and Population Research, NUS. He'll be sharing with us his work on projecting the future household and living arrangement. Indeed, very interesting topics, very diverse, all focused on economic and sustainability issues, development and sustainability issues. So please allow me to welcome Professor Lorenz Goette. If I'm sorry, apologies if I pronounce your last name wrongly, Goette or Goette. I'll let you take the mic. Professor Lorenz, please.
So thank you for having me. Today, actually, rather than giving you just one specific paper, I sort of wanted you to give an overview of what is it that we can do with field experiments in resource conservation, in particular to understand the role of attention. So let me start right away and maybe add some drama to the whole situation. I think we all know that environmental problems pose a massive challenge to society at many levels. Okay? So increasing resource consumption creates pollution, and globally rising temperatures have large economic and social costs. So this goes from impacts on health that Alberto, I think, will also talk about more. This goes from extreme weather events and that affect lives and the economy in increasingly dramatic ways. There are many channels through which resource consumption poses challenges to society. Okay. Increasing scarcity of resources also leads to regional conflicts and tensions. So this is a very multi-layered problem. Okay. Now, traditionally, the answer to how can we solve this problem of scarcity has been to say, well, let technology fix it. Okay. And so this has been a very engineering-driven approach to this problem, to say, no, well, we don't know so much about behavior. Let's not even bother to try and change behavior. let's just make consumption more efficient by making resource extraction more efficient, by coming up with new technologies, and by also just making consumption more efficient by say designing your vacuum cleaner more efficiently so that you can do the same amount of cleaning and using less energy. But increasingly, there has also been, so the more you just follow one strategy, the more, this is one of the very old economic principles, the more you run into diminishing returns. And so after having followed the technology strategy for, I would say, 150 years, now there has increasingly been an interest in asking, well, is it maybe also something that we can do by trying to change individuals' behavior? Can we find behavioral interventions that help us to use resources more efficiently and therefore to contribute to the policy goal of sustainability? What I would like to talk about today is showing you sort of a new approach to this problem that I think fits well with the theme of this forum of computational social science, because it is at the intersection of information systems, computer science, and social science. And I hope to convince you that there is a very fruitful collaboration there, both in terms of the policy impact that it can have, as well as in terms of helping us pushing the boundaries in the social sciences by better understanding what are the underlying mechanisms of various behaviors that we study. Okay? So also one reason why policy isn't relying so much on trying to change individual behavior is because there is this puzzle in the literature that many individuals state that they're very willing to protect the environment, even if it came as a personal cost to them. Yet these intentions, they rarely seem, they don't fully translate into behavior. Okay? There are many reasons. Maybe people are just saying something that is socially desirable in questionnaires when you ask them about it. But there might also be a real obstacle that stands in the way of translating these intentions into behavior. There is also something interesting happening here. Another piece of evidence that points in this direction is the observation that actually especially in the domain of sustainability, but this is also true for many other behaviors. Many behavioral interventions that just try to inform individuals, look, this is bad, this damages the environment. If you evaluate them in a randomized controlled trial, very, very often, these kinds of interventions, they just have zero effect. And so the question is, why? What is it that even though individuals have all these good intentions, we give them information, very little happens? Why is this the case? So the hypothesis that I want to propose here is to say that the information that we provide to individuals must enable behavioral control, must help them to directly translate into behavior. And so in order to do this, now we should target a specific behavior on which we provide information, and that we provide that information to the individuals exactly at the moment when they're engaging in that particular behavior. And so you see here, it says, for example, showering. Actually, it will all be showering during the whole talk today. So you will learn more about showering that you could have possibly imagined during a talk like this. Okay. And so, like I already said, I think this what I also want to highlight is, this is an interesting collaboration between very different sciences, social sciences on the one hand, and then information systems on the other hand. And I think it fits very well in the topic of this forum. So let me show you what I want to highlight today very briefly. So I've given you a quick motivation of what I want to do. I'll show you sort of the proof of concept study that is already a bit dated, and then show you sort of three very recent examples that will all build on what I've shown you in the first part. In which directions this kind of research can go and what could be the possible policy, policy implications. Okay. So let me start right away with the first study. So like I said, you're going to learn more about showering than you might have thought possible at the conference. And so let me start with this. So a typical shower lasts only 5 minutes. So you might say, why bother? Well, actually, in these 5 minutes, and so these are now numbers from Europe, we consume 7% of our total daily energy use and about 30% of our total daily water use. Okay. Of course, in very warm countries like Singapore, that number is going to be a bit smaller, but the 30% is, if anything, is even higher here. So in Europe, just to give you a sense, that's around 2.5 kilowatt hours of energy and around 44 liters of water per shower. Okay, so this is a big ticket item in terms of resource use. So if we manage to move the needle here, now we're going to have a significant overall impact. That's the hope. Okay. Showering is also interesting for behavioral research. Why? Because there is this asymmetry between the benefits of the shower that I don't have to explain to you. It's very nice to shower. But it's very hard to see what the resource use is that is hidden as we shower, because now the water just goes down the drain and is very hard to observe. Okay. And so it's not surprising that this leads to a situation where since we're not supercomputers and we're not paying attention to every detail of our lives, the resource use sort of goes unnoticed, and we may consume much more than we actually want simply because we don't see it. So this is exactly what we try to fix, that we want to make resource use visible so that resource use and the benefits from consumption are sort of on an even on a level playing field, rather than a highly visible benefit from consumption and you don't really see the resources. Okay. So let me show you how we do this. We do this with a very simple device that you can see here, and we call it a smart shower meter. So it shows you in real time how much water you're using. It's a very neat design. It's very easily installed, and it also saves all the data that is going on here in the device, the water flow, the temperature. It all saves that inside the device so we can extract it and then analyze it. And so this is joint work with colleagues from information systems, and then also with economists, former colleagues of mine from the University of Lausanne. The first data that I'm going to show you is going to be from a field experiment in the city of Zurich, where roughly 700 households participated. Okay. And so we're going to have these households in two experimental conditions: a control group that only sees the water temperature during the entire experiment, and a feedback group that during the first 10 showers also just sees the water temperature, and then we turn the feedback on. Okay. So let me show you what's happening. Well, so here you see the energy use, water use is on this scale here of the control group, and you see that not much is happening. Okay. The treatment group that gets the information during the first 10 showers, they behave exactly like the control group because they also don't get the information. But as we turn as we turn the feedback on, you see there is this immediate drop in consumption. Now it's about 0.6 kilowatt hours of energy per shower, around 9 liters of water saved. So at the household level, this leads to a very significant conservation effect, both in terms of energy and water. So let me quickly show you. So when we started with this, so this was sort of our proof of concept to say, oh look, this could be very interesting. So what we did then is several follow-up studies. One more in Switzerland, and then the second two here, they're going to be in Singapore. So in the first study, we're again with basically the same co-authors as in the first one. Now we were interested in the question, how important is the immediacy of this feedback? Okay? Does it matter that you get it right as you are in the shower, or could you maybe also get it a little bit later? Okay. Now, to do it, we introduced in a new study, we introduced a new experimental condition where, now again, we have a control group just like before. We have a live feedback condition that after shower 11 gets their feedback. And then at the end, they sort of see an overall information. So this is the German word for good. So no reference to your gut or something. It shows you now at the end of the shower, how much water have you used and what was the energy use? What was your energy use? And then we have this slight variation here that is during the shower, these individuals here never get any feedback. They only get the part at the end. Okay. So let me show you what happens here. Okay. Here again, you see the control group, nothing happens. The group with the live real-time feedback, no, consumption drops immediately, just like before. The group that only gets the feedback at the end of the shower, you see that now there is sort of this slowly developing lingering effect, but it never gets as big as this one. Okay? And in fact, when we look at the numbers more closely, we find that the orange line, that the orange, dark orange conservation effect is about 40% bigger than the light orange, the delayed feedback conservation effect. Okay. And this is where this is actually the reason why I'm here, because as we started doing this through coincidence, we started doing research on this topic in Singapore, where water conservation is a high policy priority. And together here with colleagues, we wanted to examine, well, can we do maybe a little better? Rather than just showing individuals, this is how much water you're using, can we make these effects perhaps stronger? Now, if we encourage individuals to stay within a particular limit, so by setting goals to them. Okay? There is also a considerable literature in social psychology and behavioral economics that is interested in goals, but these studies have several of these studies have limitations in the sense that when you give somebody a goal, you automatically give them feedback. Nobody properly controls for that feedback. Then many of them are very short term. Others are the ones that are longer term are correlational. So establishing causality is very difficult. And few of them try to say much about the underlying behavioral mechanisms. Okay. So you see, we're expanding. So you see here in a collaboration with colleagues from NUS, and then with some of the colleagues from previous studies. Now we implemented in collaboration with PUB this experiment in Singapore. Now, PUB wanted us to cover the entire island. So here are all the HDB blocks that we covered all across Singapore. And here, here are some of our happy study participants. The experimental conditions that we had here was again control group. a real-time feedback group, but this time they only get the naked number of how much water they're using. And then the goal condition that now initially tells you, okay, your water consumption is very good, but then depending on the goals that were assigned, and different households get different goals, but those goals stay the same over time. Once you exceed the goal, it will tell you too much. Okay. So let's see what happens in this experiment. So here, now you see what's happening in the control group. The control group sort of drifts up a little bit over time as it gets hotter and hotter over our study period. And then again, you see the immediate effect from real-time feedback. Just showing them the number alone has a sizable effect on resource conservation. So all these numbers now are a bit smaller because baseline consumption in Singapore is much lower. Okay. Now, what does adding these goals do? Well, adding the goals makes the conservation effects, initially it makes them stronger. So say if we go, average consumption is 20 liters. If we go to a goal of 10 liters, that helps a little bit compared to here. 15 liters, even better. Okay? But then as we make the goals easier, it actually works less well. Okay? So what we found in this study is that there is sort of this intermediate sweet spot of goals that works particularly well. But what's very important is that we have this benchmark where individuals have feedback, but don't have any kind of goal that they may be going for. So there is more that we can do in this study, but I don't have time to go into it. So for example, we can also talk a little more about mechanisms, but I'm going to skip that. I'm going to skip that now, because let me use the 1 minute that remains to just talk a little bit about spillover effects of feedback on other behaviors. Okay. So following this study, PUB was very happy with the results, and it inspired them to launch an even larger policy pilot in around 10,000 BTO flats that were completed in the years 2019, 2020 to equip these flats with this type of technology. And what we were interested in this context, is to say, we're giving this strong behavioral impulse on this one behavior. Does it also affect other domains of behavior? And so in particular, we were interested in that because it's not clear in which direction this could go. This could be a positive spillover in the sense that once I'm drawing your attention to water use in showering, maybe you're also becoming more economical with water in other domains. Or it could produce the exact opposite. Okay? It could produce the effect that because you're conserving more water here, now your attention is used up here and you're paying less attention to other behaviors. Or maybe you feel that because you ran the extra mile here, now you're allowed to eat the whole piece of cake in terms of increased water use for increased water consumption for other uses. So measurement in this literature is key. And Singapore was great because we conducted these experiments in HDB estates where it's very easy to read off the data for us. It's very easy to recruit participants, and there is a genuine interest in participating in this study. Okay? So this is joint work with colleagues from the Public Policy School. And let me, in the interest of time, perhaps jump straight to the results. So, not surprisingly, turning on the feedback, it just works every time. Okay? And here the effects are around 5 liters conservation effect. When we aggregate this up to the whole day in terms of what these households save for water use, it's around 30 liters. Okay? However, when we look at total water use at the household level, we see that the conservation effect is smaller. it's only about 24 liters. So a third of what is saved here gets lost in the process in terms of higher water use for other behaviors. So we thought this is interesting because it really highlights that you have to be very careful with using these types of interventions, because they can affect behaviors in other domains on which you don't provide feedback. Okay, so I'm already a little bit over time. So I can talk a little more about implications if there are questions about this. So why don't I stop here, and thank you for your attention.
Hey, thank you, Lorenz. Very fascinating, a very impactful and directly relevant applied type of research that really shows human behaviors and as they happen. Okay, so let's move on to our next speaker. Okay, let me just. Can we have Professor Alberto Salvo from the Department of Economics and the Global Asia Institute to talk about household responses to environmental degradation. So, Professor Salvo, can you have the mic, please? Thank you.
And thank you, Elmie. Just to confirm that you're seeing my slide deck.
Yep.
Great. Clear. Thanks, Lorenz. Very good. So I want to start by thanking the organizers, the Dean's Office of the Faculty of Arts and Social Sciences, for putting together this forum, and to those of you in the audience. What's the objective today? I'm going to continue along the same objective that Lorenz described, that I want to showcase policy relevant computational social science. And it's great to present right after Lorenz, because there's a lot of complementarity, and I'm going to be looking at this interaction, this very complex interaction between society and the environment. I'm going to just fast forward to show you a diagram. The complexity in which nature affects society, and society also affects nature. So understanding the human and natural world. So that's the space that I'm going to be talking at. And I'm going to be speaking specifically on work conducted in Singapore. So I'll be talking about what is currently material that is in 3 different papers. 2 have been published. 1 is still trying to get published. And I'm going to be looking at how Singapore's households respond to environmental degradation. And specifically what I have in mind in a city in the tropics is heat, of course, and also air pollution. Okay, so Singapore also suffers from variable air pollution. And the way that I'm going to be looking at the response by households is both, how long do they spend at home and what do they do at home, as seen from, for example, utility billing data, electricity and water, and also, where they are as described by their mobile phones. So this is, data based on pinging phones, and as well as commuting, so individual farecard data. So where is this going? It's very clear that households care about the ambient environment in which they're in. We see this through their behavior. This is observed behavior. The way they respond to the environment when it degrades reveals that they care about it. And this is very relevant to policies seeking to protect the environment. So the first paper I want to talk about is looking at heat. And this is not heat in 2050 or 2100, it's heat today. Singapore is in the tropics, as we all know, and heat does vary within the year, within the month, day to day. And one way we can look at the effect of heat on households is how much they consume of electricity and water when temperatures vary. This is not only relevant for Singapore, but throughout the tropics, there's a very fast urbanizing population numbering up to 4 billion people. And so if you think of Singapore, what we learned about Singapore might tell us something about how urbanization will play out in the next 10, 20 years across the tropics. So this study is based on data graciously provided by SP Services, which bills the universe of households in Singapore. It's based on a random sample, so a 10% sample of households, and it tracks their consumption of utilities, water, electricity, and natural gas over time. So you can look within households. There's obviously a lot of differences across households, but with this kind of longitudinal panel data, it's obviously a lot of data, but if you handle it appropriately, you can look within household over time and control for all sorts of reasons why households vary across between one another. This is also data over time. It's very important because you have to control for things that vary over time, such as seasonality. And what's very interesting about Singapore is, although it is a rich city-state in the tropics, there is variation in the cross-section. So there is, there are higher income and lower income households, and they have varying access to defensive capital, such as, for example, air conditioners at home. All right, so looking across time around over 3 years of data, we know that there's an annual cycle. So in this panel on the top right, we know that temperatures do rise in July and August relative to October and January. But even within a season, you do see variation from day to day, week to week, and that's what we're going to be looking at. I'll skip the others in the interest of time. So here's one result. Looking at heat, when Singapore gets 1 Celsius warmer in let's say, in a billing period that is warmer in a given year compared to the same season the year before, we see a response by way of water consumption and electricity consumption at home. Now, what's very interesting is that the response varies across different types of households. So we look at the high end, we take condominium dwellers in condominiums, which typically have higher prices, higher house prices. We see that when there is a warmer period, what shoots up is electricity consumption, which is this horizontal axis. So this is the electricity response to an additional Celsius of temperature. And so we have a very big response, a 1 Celsius rise in the average temperature over a billing period. It leads to 9% increase in electricity consumption and very little or no response in terms of water consumption. So this won't surprise people who have air conditioners at home and perhaps find electricity prices to be not so high, that when it gets hot, we just turn on the air conditioner, we turn down the thermostat. Now, at the other end of the socioeconomic spectrum, in 1, 2-room HDB flats where the penetration of air conditioners is much lower. So for example, during this time period, 2012 to 2015, if you look at 1-room HDBs, the proportion of these dwellings that have an air conditioner is only 14%, 14%, compared to condominiums where it's pretty much saturation. So all condominiums have at least 1 air conditioner unit. And what we see here is that when it gets hotter, we do see an increase in electricity among these lower income dwellings. For example, they might turn on the fan. There might be other reasons why they're using electricity more. But the big response that we see is in terms of water. So it's a different strategy for achieving heat relief based on water cooling. Okay, so it's this differential response in terms of the usage of resources, electricity or water, to heat in the socioeconomic along the socioeconomic spectrum. So this is pointing to a concept that is, we call this distributional justice, that the different income groups in the population will suffer differentially from environmental degradation here in the form of heat. The rich, the well-off have access to, are willing and able to use air conditioning. The lower income, they, even if they have air conditioning at home, and only a few do, they might still find it very expensive relative to their income. The right panel, so the left panel is showing us how the penetration of air conditioning varies across the income dimension. So it's typically what we refer to as an S curve. So here what we're seeing in Singapore is perhaps the top part of this S, that we do see an increase all the way to 100% among the higher income groups. On the right panel, we're dividing a household's electricity consumption as a share of its total expenditure, this brown curve, and the blue curve is showing us the water expenditure as a share of total expenditure. And what this is showing is that as incomes rise, as you look across the income distribution, we know that these goods, the proportion of spending on goods tends to fall as incomes rise, but it falls much less for electricity. And that's simply because there's this energy inequality, which is more pronounced than water inequality. Okay, the rich use a lot more electricity relative to the poor, compared to how much more water they use relative to the poor. Okay, so this double difference, if you will. Okay, so I've been talking about heat. I want to spend a moment talking about pollution, air pollution, also as a form of environmental degradation. It's using the same data set, and the idea is very similar. So I'll be very brief here. This is another paper, and again, it's looking at this distributional justice dimension, or how the lower income households might be less able or less willing compared to other demands on their income to invest in defensive capital when the environment degrades. So air pollution in Singapore. So we're not talking about heat. And here I want to focus on one measure of air quality that is monitored by authorities, including in Singapore. PM 2.5 is a certain size of particle that is, in ambient air. There's a lot in this panel. There's the two axes are responses. The horizontal axis is a response that I already discussed. Electricity use, how it changes with temperature. So I'm not going to talk about this horizontal axis. It's what I already discussed. On the vertical axis, it's the other response that I'm now talking about, which is how electricity consumption changes with air pollution. And again, the message is similar, that when you look at the high end of the income distribution, when the environment degrades, here we're not talking about heat on the vertical axis, we're talking about air pollution, we see a disproportionate increase in consumption of electricity among high income households. So for a 10 microgram per meter cube, that's a certain dose of pollution, a certain concentration increase in these ambient particles. We see condominium dwellers increase their electricity consumption by 1.5%. And that's almost double that of a one-to-room HDB flat. So for the same increase in dose in ambient air pollution, as measured by PM 2.5, the increase in consumption of electricity among these low-income dwellers is 0.75%. That's half of a condominium dweller. Again, it's talking about this environmental justice, or this inequality in defensive expenditure. Another way of looking at this is doing a survey of energy behavior. So this was a survey that I conducted with an online panel. And so this is a within subject design. You ask a respondent how he or she typically sleeps in terms of cooling, whether it's with the window open and natural ventilation to catch some breeze, or is it with the window closed and turning on the air conditioner. So you ask that question before any sort of priming. And that's this normal weekday. So the first thing to note is you see this energy inequality, that if you are a respondent in a condo or a house, you're much more likely to be sleeping with the air conditioner on compared to a dweller in a 1 to 3 room HDB flat. So that's a normal weekday. Now within subject design, the online panelist is then shown a picture of Singapore during a haze episode. So there's some landmarks of Singapore. There's the Marina Bay Sands shrouded in haze. And then the respondent is asked the same question. And unsurprisingly, what we see is an increase in the proportion of households who will now be sleeping with the air conditioner on. So dwelling type, you can think of this as an income measure. Also, whether the household owns a car or not is telling us something about income. And again, you see this energy inequality. Okay. Yeah, one thing that I'm not showing in this slide, which is also very interesting, and it comes out of this study, is how younger respondents are much more likely to use air conditioners when they're sleeping compared to older respondents. So it talks about a concerning, a challenging lifestyle change, which going forward will be something quite challenging to change, and especially as the climate gets warmer. All right, so this is pointing to a, if you think this is excuse the math here, but I'll tell you this in words. If you think about the environment, what is one key reason why the environment matters is that it maps onto people's health stock. And whenever you think of changes in the environment, so this change in the environment relative, how changes in health are influenced by changes in the environment, you can think of two pathways. One is a direct pathway, which is if you were not allowed to respond, if we were sort of static beings and the environment were to change, but we cannot change our behavior, that would impact our health. That would be a direct effect. But then, because we are precisely human beings and we respond to the environment, there's an indirect pathway in which the environment influences our behavior, and our behavior then moderates the effect on health. Okay, and so I want to spend a moment talking about why this is very policy relevant. There's a very interesting episode in an exchange between government officials and researchers based in the US. In 2015, there were 2 months of very high pollution levels. There was a 2-month episode of a lot of burning regional land fires upwind and in proximity to Singapore. And around a year later, a group of researchers based in the United States published this study estimating how many deaths happened in different countries of Southeast Asia because of these 2 months of land burning. And so they had a list of different countries and different levels of mortality. And for Singapore, they came up with a figure of 2,200 premature deaths. So that was published. And within a day or so of the publication of this study, the Ministry of Health, welcomed the study, welcomed that, it's important to have more research on the impacts of haze, but saying that in the specific case of Singapore, the study was not reflective of the actual situation. That Singapore, looking at the data, there were not a 2,200 increase in deaths. And so I think the key reason why this might not have been seen in Singapore is if only because Singapore as a whole, as a nation as a whole, has invested in so much defensive behavior. Okay, and so much defensive capital and health systems and windows that are able to shut and air conditioning and so on. So it would be the second term in the relationship that there's this capacity to adapt. So given the data that's available on health, whether it's polyclinic visits or mortality, it does seem to be the case that increases in PM 2.5, at least over the periods that I've been able to look at with the data that are available, quite an aggregate level. It's not very disaggregate, but it does seem to be the case that there isn't a significant increase in mortality when there's more pollution, but also in heat. Okay, so it seems that Singapore is quite adapted to the current variation in its climate. Okay, so it's the current climate, hotter periods versus less hot periods. In terms of polyclinic visits, which perhaps are, they're more responsive. You do see increases in, for example, infections in the upper respiratory tract when there is more PM2.5, and you do see decreases when it's warmer. Okay. Okay. Right. I want to finish my talk. I have around 4 minutes talking about some current work, and it's along the same, narrative. So this is with co-authors in the Faculty of Art and Social Sciences. We've been looking at how, based on phone, location and time resolved phone data and commuting data, how Singaporeans respond to variation in heat. So in terms of mobile phone data, we have certain locations. They're not, this is a very expensive data set. There are not that many locations. This is hour by hour. So both for malls, for offices. So these are indoor spaces, parks as outdoor green spaces, and some residential subzones. And this data is complemented by a lot of data based on individual level farecard data. So this is longitudinal. If you use your farecard, your EasyLink card, you've been using it over time, this would be in our data set. So every one of these dots on the top left panel are bus and rail stops. So this is where people tap in and tap out, who take public transit. These are the stops that are by residential areas. There are stops by industrial areas, by the CBD. So these are workplaces, and also stops that are serving malls and parks. Right. So the first thing that I want to mention is, in contrast to a recent literature that documents very limited adaptation, historical adaptation to temperature variation. So this is looking at places like, for example, the United States, Europe, and in my view, documents some very surprising adverse effects, some effects that seem supersized. So when it's hotter, there's a big reduction in, for example, industrial activity. Judges are less productive, even judges who work inside air-conditioned offices. So there's a literature that's documenting very large adverse effects from current weather variation. Okay, it's very hard to go forward 100 years and predict what variation that kind of timescale will be. Now, what's surprising to us when we looked at this data is we do not see adverse effects, at least where we're looking at. We're not looking at, for example, construction workers. We're looking at office workers. We're looking at mall goers. And so both in terms of workspaces on the left panel, so offices and malls, we see increased attendance on days that are hotter. Okay. Our interpretation of this finding is that these spaces, these indoor spaces, they double as, so they offer a cooling co-benefit. So these are places that are air conditioned. Anybody who's been to Singapore will know that. And so on hotter days, all else equal, it's more appealing to go to an air-conditioned office or an air-conditioned mall. So I think the key thing that I want to emphasize here is we don't find adverse effects in the data that we're looking at, okay, which is speaking to Singapore's adaptation, historical adaptation to its current climate. All right. The farecard data, since we know where people depart in the morning and go back in the morning, in the evening, we can infer what their home stop would be. So we can look at people who are departing in the morning from neighborhoods that have more 1 to 3 room HDB flats, so lower income compared to other neighborhoods which have 4 or 5 room condominium apartments. And we can compare the response of low income households to that of high income households. And what we find is when it gets hot, we see an increase in mall commuting to malls, but particularly among those who come from low-income households, low-income neighborhoods. Which is interesting because malls are interesting on hot days because they offer cooling, but particularly if you're not willing or able to use cooling equipment at home. Okay, so I'm finishing up. We have interesting results in terms of parks. So on hot days, we see an increase in attendance to parks, particularly in the late afternoon, early evening hours. Talking about the ecosystem services of these urban green spaces, and I'll wrap up. So 3 things I want to talk about in this takeaway. One is this vicious cycle that environmental degradation induces through the human response more environmental degradation. So pollution begets pollution. So you've got air pollution, and that's going to increase the demand for electricity, and the way we generate electricity is using fossil fuels. So it's this vicious cycle of how degradation begets degradation. There's a point about environmental justice that even in a rich city, let alone across rich and poor countries, there is inequality in defensive expenditure. In terms of historical adaptation to its current climate, in the data that we're seeing, Singapore gets a pass. So this contrasts to literature that many rich countries don't get a pass to their current climate. This is seen from revealed demand, right? What people do on hotter days. So it speaks to this Singaporean exceptionalism, okay? Then the question is, well, how about in 2050 or 2100 with the fast changing climate? How long can Singapore remain exceptional? Okay, so I'll stop here and thank you for your attention.
Thank you, Alberto. Fascinating data and very, very insightful interpretations. Without further ado, let's go next to our third speaker, Professor Feng Qiushi, who will be sharing with us his research on projecting the future household and living arrangement. Qiushi, please.
Okay, thank you very much, Elmie. It's truly my pleasure to be in this panel. Particularly, I'm very happy to present after Professor Goette and then Professor Salvo. I think my presentation will make a good complementary part for their presentations because both of their studies are focusing on the household-based analysis about energy use or response to environment. Particularly, Professor Salvo raised a last question in his presentation. That is, what will Singapore do for the in response to the future change of climate? I guess my presentation will more focusing on the other side, like what will be the future household of Singapore? That will be another side of the story. As we all know, that household in our world are experiencing substantial transformation, and some of the very significant transformation include the trend of solo living. In many developed societies, solo living is become the most popular living arrangement. In Germany and Norway, about 1/3 of the household are already made of the solo livers. Even in big countries such as China, the one-person household will be kind of tripled from 2010 to 2050. Another significant implication for household transformation is when we have smaller household, then who will take care of the elderly people? This might not be a big problem for the Western society, but for the Eastern society, where the co-residence culture prevails with the Asian value featured with filial piety, and who will take care of the next older generation will be a big problem. And that becomes, the elderly living arrangement become a very key issue, and which determine the demands of the long-term care in the future. So these are the two major implications. And another major phenomena for demographers is the growth of household is actually already been faster than population. And this has been happening for a long while. according to the recent 6 decades. As you can see in Brazil, India, USA, France, particularly in Japan, the growth rate of household has been faster, much faster than the growth rate of population. And what will be the implication of this? I would like to go back to the topic that Professor Goette and Salvo has been talked about. That is the implication for the energy use and environment. Because water, electricity, gas, vehicle, furniture, banking, finance, and many, many other resources, commodities, and services are often purchased and consumed by household rather than individual. And therefore, the smaller but fast increasing household is really not a blast for a sustainable future. We can easily imagine that the usual family, if made of 2 couples, and if they got divorced, then make up 2 one-person household. In that kind of scenario, they will need 2 refrigerators. They will turn on the icon, 2 icons at night. And that means the energy efficiency for the entire society will be threatened. So this is one of our simulation if to try to see the energy consumption based on population or based on household. And we Professor this is a project led by Professor Zheng, who has focused on the energy consumption in Hubei province of China, a very typical province. As you can see that if analysts rely on the population data to project about the future use of energy, water, and fuel, and there will be a big underestimation. And all those kind of phenomena remind us of the necessity to develop a reliable method to project the future change of household and a living arrangement. There are 3 major methods in this field. The head-shape rate method has been broadly used for the Census Bureau among the the statistic department of different government. And recently, there are 2 kinds of other method has been developed. The micro simulation use an agent-based method. Another one is the micro simulation. And I'm introducing you today the so-called Profemi method, which is developed by Professor Zheng Yi and then his team in the recent 2 decades. Profemi is a micro simulation method which simulates the change of household and living arrangement based on group of individuals by age, sex, gender, race, marital union status, and number of residing children and parents. And it is a cohort component method, and that means the projection of the future are conducted based on the current cohort. So is it a family union and family dissolve is quite complicated, as you can see, because it involved with birth and death, the 2 major demographic events. It also centered on the marriage transitions, not only get married or divorce, and also other new type of marital status, such as cohabitation. And also it relates to the events such as adult children leaving the parental home. All these kind of demographic events, if we model them together, mathematically, it is a very daunting task. And that's why the first question is how demanding it is in terms of data. And then based on the innovation computational strategy, Profemi has made use of most of the conventional demographic data. This is a comparison between Profemi method in regard to a standard population projection. As we can see, Profemi only asks a little bit more, not too much. And number 2, I want to tell you that actually tomorrow for the keynote speech, Professor Zheng Yi will have a 1-hour keynote speech to tell about you the detailed mathematics about this method. But here I want to wrap it up by saying this method has been very extensively validated in the United States, China, and in many, many countries. And just very recently, the method has been supported by many institutions, including the Asian Population Association and CIPR at NUS. And it is now under the support of United Nations Population Division to be applied to multiple countries. Today, my job is to illustrate some of the very recent progress of this method, which is highly related to Singapore. Since the late 1990s, the researchers and policymakers have demanded household projection at subnational levels, such as at the provincial level, the county level, the city level, or even smaller area. Because in these subnational levels, there is very real governance demands for the intelligence and information about the structure of household, how many people are living with others, and then the living arrangement of older adults. For this kind of data, they will be used to inform the policy making procedure, to help with the public budgeting. But unfortunately, the subnational data tend to be quite limited. Unlike the national data, usually the countries have census data. For the subnational level, many, many key data are missing. And therefore, methodologically, we need to accommodate this kind of limitation. Theoretically, Perfemi proposed two assumptions. That is, in order to do household and living arrangement projection, we could adopt the national level schedule data, but use the local level demographic summary data. And this makes theoretical sense because unusually the demographic events, its schedules should be quite consistent across different parts of a same society. And that makes this assumption have a very solid theoretical base. And in order to show this assumption is right, we did an application in South California of the United States. We cooperate with SGAG, that is the Southern California Association of Governments, which is the official managing agent for the 6 counties in Southern California, including Imperial, Los Angeles, Orange County, Riverside, San Bernardino, and Ventura. As you can see, of course, Los Angeles has the the highest amount of population, as you know about the United States. And this agency is actually the largest metropolitan planning organization in the United States, with an area of more than 38,000 square miles. And we believe this is a very good case to illustrate the model of Perfemi at the county level. Before we do a projection and to show the potential that how Perfemi could do for the subnational level, for the cities and counties. For that, I would like to say, like we would very much like to do the similar kind of analysis for Singapore, because those kind of future dynamics of household will be very relevant for the social plannings for the Singapore government. But before we do this, and the first step for us is to do a validation. This kind of validation is designed like we get the data, the past survey data, in 2010, and sorry, 2000. The data is very available in 2000, and then we use the data in the census 2000 to project 2010. And because 2010 data is also available, and therefore this provides us to see, we use the projected data to compare with the real observed data. In this way, we could validate the method. As you can see, most of the comparison of the real data and projected data have a very little error. Most of the errors are less than 1%, and all of them are lower than 5%. Okay. So after the validation, I would like to show you the use of Perfemi. First of all, this method could quite accurately project the population size and number of households. And as you can see, in Southern California, the largest county, Los Angeles, will increase quite fast in terms of population and as well as household numbers for the next 30 years up until 2040. But you can see those small-sized counties actually got even higher rates of increase. The second result we can see from this is obviously the increase of household numbers actually faster, larger than the increase of population in South California. And this is a general trend we have been talking about because of the smaller size of household. And Perfemi can clearly differentiate by more than simple numbers. We could check about the racial distributions, which is a major concern of the local government. As you can see, in all 6 counties in Southern California, Hispanic people will increase in proportion. And for some of the counties, actually, it increased quite dramatically. At the same time, the non-Hispanic white people are declining in almost all of the counties. And in some of the counties, like Los Angeles, we can see a quite significant increase of the non-Hispanic others. Demographically, they are mainly made of the Asian people. Yeah. And the major product of Perfemi are about the household. And this is how Perfemi could do in terms of household projection. We could project quite detailed household by household size. As you can see, in Southern California, the average household size will decrease from about 3.1 to 2.88. At the same time, one-person household increased about 1%, and two-person household also increased. And in terms of, besides the household size, we could also project the household types. You can see the 8 types of household types, including the one person only, one person and other, the married couple with children or without children. These are all policy relevant target populations. As you can see clearly, married couple with children declined for 3%. On the other side, cohabiting couple with no children increased from 2.6% to 4.2%. And this kind of household type could also be analyzed with race, which is a concern of the government. As you can see, for the one-person household, about 50% of the local Black people are living alone. And the same phenomena also apply to the white, the Asian, and Hispanic. But obviously, the Black people stands out significantly. On the other side, when we see the household of a married couple, this is a quite traditional type of our society. You can see the non-Hispanic Asian people, they are still maintaining like more than 50% of them are living with marriage. But you can see the Black people only about 20%. They are living with marital status. So this is by race. And lastly, as I said, one of the major goals of PROFEMI is to check about the living arrangement, particularly to serve for the elderly care sectors. And we could also project the future changes of how elderly people will live with others. As you can see, we could project the living alone situation. And not only that, we could also differentiate their marital status, because people could live alone for being never married, or being divorced, or being widowed. And we also could have a married couple not living with children, or cohabiting couple not with children. And we also have the other major types of living with children differentiated by different kind of marital status. And of course, we also have some very special type of living arrangement, such as institutionalization or live with others rather than family members. Yeah. We particularly focus on those people who are aged, but also live alone, because literature suggests this group of people are more likely to have mental and social isolation. So these are the solo livers who are aged. We could differentiate by different gender and different marital status. As you can see, obviously, widowed women are the major force. Consist, in all the solo livers in the Southern California. By different, this is the true for different, race and ethnicity status. I would like to end my talk here, and thank you very much. And any welcome, I will welcome any comments. Thank you. Yeah.
Okay, thank you, Qiushi. So we are left with roughly around 15 minutes for Q&A. Anyone who has any questions to ask? Let me just check. There's nothing in the Q&A currently. So any participants have any questions to ask any one of our speakers? So feel free to ask them right now. You can use your raise hand function to actually ask any questions that you have. Okay, perhaps let's see whether we have anyone. Just go through.
Sorry, Amy, can I ask a question?
Yeah, sure.
Yeah. Okay. I have a question for Professor Salvo in regard to the study of the health inequality issue, the social economic inequality issue. By differentiate, the Singapore inequality, you are mainly using the one bedroom, one HDB room, two HDB rooms, three HDB room. Is it, I mean, this is, of course, I believe this is a very effective measurement, but do you have any income data to really show that people are living in a smaller household size have lower income? Yeah, can you link to income in that sense? Yeah.
Right, so just one clarification, your question started by saying health. So health is the only measure that I have no, I don't have an income resolved measure of health. Okay, so health is only very aggregate, right? So a time series of polyclinic visits or monthly mortality for the whole country.
I see.
Okay, so that's just a clarification. Now to your question, the household expenditure survey, which is published every 5 years, it's a quinquennial survey. It does provide this correlation between dwelling type and income, right? So how the joint distribution of income and dwelling type. So you see this very clearly that there's even a panel in my talk where you see how income rises as you go from, it's from 1 room to 2 room to 3 room, 4 room, 5 room, and then to condominiums. Yeah. So that's one thing. You do see that in the household expenditure survey. The other income data that I got access to was through the LTA has a household household. It's the HITS, the interview, travel, survey, or something. I'm getting the acronym wrong, but then they do survey households, commuters, and they get the income, and they get where people live. So you have the joint distribution, and it gives you the same pattern. And what's also interesting about the HITS is that you also know where the respondent lives, and so you can get a neighborhood level income measure.
I see.
Right, and then you can see besides dwelling type. So let's fix the dwelling type. Right, it's a 3-room HDB. Let's look at that location, what the average income is from the HITS, and let's see how that maps onto electricity. So you do have some, kind of like a roundabout way, but you do get some income measures.
I see. Thank you. Yeah.
We can talk further if you're interested.
Sure. Yeah.
Thank you. We do have a question coming in from Aditya Natamuni. There's a couple of questions. Yes, please go ahead.
I have a couple of questions for Professor Lorenz. First of all, thank you for the paper. It was very insightful. Like, my first question is, you have spent time on talking about individual feedback, as in, like, what is the feedback on how an individual uses the resource. So I was just thinking, I just want your opinion on whether if you think that social norms could play a bigger role, like could have a bigger influence, as in, for example, in the showering use. Do you think, like, if we compare individual use to users in the community, do you think there will be a bigger effect as compared to individual feedback? Like, so this is my first question.
Okay. Yeah, so I think this issue with what other, so I think one research agenda is really to see which tools work best. And so perhaps the one thing that that I want to say here is one of my pet peeves actually is there is this literature on these so-called home energy reports, right? Where say we get those too, right? With every bill from the SP group, you get this comparison: how much do you use, how much do others use, and so on. The reason why it's on basically every electricity bill is because there is a series of studies from the US that show that these types of comparisons, they're quite effective in reducing electricity use. However, they're effective exactly in the US. And the one difference between the US and many other countries is that compared to Europe, compared to Singapore, most parts of Asia, electricity use in the US is just off the charts high. And that has many reasons, it's it's like 3 times what it is in Europe, per household. And that's not because the households are bigger, that's just because they're using more. And so, when these interventions were brought to Europe, they actually worked much less. They actually worked much less effectively than in the US. They led to just a very small reduction in electricity use when studied in Europe.
So this was social norms, right?
Right. So this was social norms that actually, social norms per se, I don't think they work particularly well. But again, because it doesn't solve the problem that there is just a lot of stuff happening in our lives, and how would you remember whatever it said on that bill from SP? So what actually we are running an experiment where we are trying to sort of show you in real time, or remind you in real time of these social norms to see and it seems that actually works a lot better than just this sort of this very aggregated kind of social norm that we are trying to induce. So so really one of my pet peeves is don't generalize from studies from the US with regard to resource consumption. It's an extreme special case, and many things that work there, they won't work anywhere else. It's sort of like, say, weight loss for an extremely obese person versus, weight loss for a person who just needs to lose a few pounds. And the US being the extremely obese person. So I'm very, very skeptical of all the studies that come out of the US, because they're really conducted in a very special environment with extremely high energy use.
Okay, thank you, Professor. And my second question is, do you think that if we were to convert the water shower use in monetary terms, do you think that will have a greater effect?
Right. I'm not sure, right? Because I think it depends on, I think this could be one of the cases that could actually seriously backfire, in the sense that, say a shower costs roughly 20 cents. Okay? So then, I think the effect that we may generate is actually that a lot of people say, you know what, those are the best 20 cents I've spent today. Let me add another 5 cents. Okay? So, I think in the domain of resource conservation, I think we're much better off highlighting, just helping individuals see what they're actually doing, and highlighting the consequences for society, rather than just highlighting the monetary costs to themselves. It may well backfire.
Thank you so much, Professor.
Okay, thank you, Aditya, for the questions. Anyone has any other questions? Otherwise, I have quite a number of questions myself. Perhaps I can just ask, and for those of you who have questions, can you just prep your questions? Okay. Well, I have so many questions actually, but let me ask Alberto first. I think in the overall finding, I think there's a very interesting proposition that you have found based on your series of studies and what you have done, in that pollution begets pollution. And I think that's a very vicious cycle. And I kind of agree, and I see where the findings are alluding to. My question is the opposite, does the opposite hold true? In that, is there a virtuous cycle in that non-pollution or, environmentally conscious kind of behavior and habits begets more environmentally conscious behaviors? Or is it not equal, or can we expect something equal? Or maybe you have done research in that area that shows the comparison between a virtuous and a vicious cycle.
Yeah, that's a good question. The research design in these studies is based on, typically the thought experiment is you take the same individual in the same season, everything is the same, and you just change the environment up or down. And so the design is that you're not different. You're assuming there's a symmetric effect relative to some mean. I think so my sense is that we're in this kind of work, we're not looking for some asymmetric response, right? So if you make the ambient environment higher quality, right, then people will use less resources, right? They'll open the window more, they will shower less, they'll use less air conditioning, they'll use less food delivery, right? But I think it's an interesting question you're posing, right? In what settings could one think of, maybe through habit, right? Habit formation, right? If you've got a very high dose of environmental degradation and that sort of induces people to adopt a different lifestyle, different habit, right? Then when things get better in terms of the ambient environment, they just carry on. So one of Lawrence's co-authors, our colleague Sumit Agarwal, I remember he's got a paper looking at precisely, I'm going to misquote the paper because he's got so many different papers as well, looking at resource conservation, but there's some setting, maybe Lorenz can correct me, in which, for example, there's construction in a neighboring a building, and people obviously don't like the noise, don't like the dust, they close the window, and then you see increase in electricity consumption. And then when the construction goes away, you still see for quite a while higher consumption, right? And so it's like the pollution begets pollution, but when the pollution goes away, you don't get the virtuous cycle. So I think I can think of that kind of results, but that's a very good question, Elmie. And Lorenz, please, if you can correct me if I misquoted the study, but it's this idea.
Yeah, Sumit writes papers faster than I can read them. So but right, I think you described it exactly right. We tested this in an experiment where we turn the feedback on and off, and so say you get feedback on how much water you're using, and then oops, all of a sudden it's gone. And then we test how much does this persist over time. And actually we also find a fair amount of persistence. But I think also the last study that I really had to rush through, I think it shows that it's a very difficult path. Now that on the one hand, you can have these persistence effects from the behavior that you're targeting, but if you're measuring only that behavior, you may actually miss quite a bit of the story, because targeting one behavior could have negative effects on another. So it's right. It's a very complicated situation that requires a lot of very detailed, very careful and detailed studies.
Thanks, Lorenz. In fact, you've just answered the question that I had with your study or your presentation. So in the situation where you actually remove the stimulus or reverse the stimulus on a participant or somebody who's already receiving it and providing positive behavioral feedback, which you still see persistence. And I think you've just mentioned that there are some persistence. So you've just actually answered my question. Okay, we have a hands raised here. I have one question for Qiushi, which I'm burning to understand or to hear from him or his answers. But that's Sophia. Can you ask your question first?
Yes, thank you. I would like to ask a question about how can we teach people to change their lives to save our environment? For example, we can be responsible to save the energy, water, and start to dispose of the trash, and just to make our life not so much comfortable as it was before. So how can we teach that people to do? Like, we cannot be all responsible for that.
Okay, thank you for the very good question, but I would leave that question to the end, where each of our presenters, because that's a big question on, basically just sum up your research and share with the audiences how can we teach or how can we educate, how can we inculcate positive human behaviors in terms of conservation based on your research. So Sophia, we'll hold that question to the end. And maybe just one question for Qiushi, which I think is well, let's so Qiushi, you raised a very interesting question. It might be a policy question more than a research question that that you raised about who will take care of the older generation. And based on your research, you really dissected and went really deep dive and into the different demographic segments and the pattern behaviors. So my question then is, from a policy perspective, why can't the same principle of parents needing to take care of their dependents, i.e. the children, apply to children needing to take care of their parents as dependents? So basically, why can't we make it a policy decision where a parent then take care of their a child then take care of their parents? I know it's largely policy, and this is not a policy forum, but if you can relate it to any part of your research or insights, that would be interesting, because I've been thinking about the question myself. Alberto, you raised your hand, but let me get back to you soon.
Thank you, Elmie. Actually, your question remind me about the long debate, actually, previous debate in Singapore about whether Singapore need a law of maintenance parents. And people will argue about that, like, can we regulate love? And that is a very normative debate. I don't know what to say. But I just want at one point, along this very interesting line, I think Singapore has a very special solution for it. Although Singaporeans are living more in a small household, but I see the government is promoting this kind of nearby residence between children and parents. And I hope that will be a solution for many, many societies. Thank you. Yeah.
Okay, thanks, Qiushi. Alberto, you raised your hand. Would you share something and maybe answer Sophia's question on what would you?
Yeah, so mine was a question for Qiushi. I really like the way you motivated your study, and I can understand that projecting population size and composition is already a super important task. I would like to encourage you, if this hasn't been done in the literature, to go back to your motivation and push that projection all the way to energy and air conditioning and emissions, right? So you see these papers published in these really top journals, PNAS, and looking at global projections of air conditioner use in 2050, right? And because they're global, they attract all this attention. So I think if that hasn't been done, it would be really cool if you could take it back to energy, right? Working through these smaller households. I thought that was really interesting.
Thank you, Alberto. I mean, that's a great suggestion. I mean, similar work has been started in America, and I'm the person who really want to push it in this part of the world, and sincerely hope I could have a chance to cooperate with you. Okay, thank you.
All right, thanks. In the spirit of cooperation, and we still have to answer Sophia's question. So perhaps Lorenz, would you go ahead and sum it up in what, based on your research, what can you share?
Yeah, I mean, I think teaching, just teaching sort of better behavior, I don't think is gonna be working. There are many studies that try this, that try out select in a randomized trial, teaching good behavior to one group but not the other, and the differences in many cases are zero, exactly zero. So I think it requires like a complex mix of. Now, first of all, we have to see what are the consequences of our behavior, and then we can then we can teach, I think, individuals in different ways. Either by highlighting what is the environmental impact of this kind of behavior. I think that in many cases the teaching has to go through sort of very specific routes, and that's what makes it so hard. Because there are so many behaviors that we need to target, right? So Sophia mentioned waste, recycling, we have energy use, we have mobility behavior. It's just unfortunately, I don't think there is like a simple one size fits all behaviors type of intervention.
Thanks, Lorenz. Alberto, would you like to sum up?
Yeah, I think that's a very good answer. So let me add on it. I think people support good policies, even though they might be a little peeved that they have to now do this or that they previously didn't have to do. So to the extent that we need support of tough policies that will have to come, right? I think it still is very important to educate the population at large. So it's very important to promote education of what's happening in the world around us, right? Why talking about the climate crisis, how we all play a role. Because then when policies come, they will be more supportive. which is the big concern any politician has, right? That, you know, if I take these tough measures, then I'm thrown out of office, right? And so even if, you know, left to their own devices, individuals might not behave that well, even if you tell them what good behavior is, right? Secretly, I think there's something good inside most people, the vast majority of people, that, you know, they kind of know why that policy is coming and why it's enacted. And okay, you know, all right, I'm not happy because it's going to be hurting me personally, but since it applies to, it's like kind of mask wearing, right? We understand why we're wearing masks, and we're not, most of us, right? It's not become a political issue, right? So I think that kind of education and, you know, being candid with the populace is so critical. And I think that has been absent in climate change. It's only very recently that it's become center stage. And we're beginning to hear people in government everywhere, you know, just talking what was obvious 10 years ago in the scientific community or 20 years ago. So I think that in a way, you know, I draw some comfort from that, and I'm going to stop on that positive note.
Thank you, Alberto. Qiushi, would you like?
Oh, I have
to sum
a
up?
very short answer for this. I mean, in order to better protect the environment, please better protect our family. Yeah.
Sure, very related to your research, actually. Okay, so welcome. Thank you everyone and thank you for the speakers. If you just you know, just a give quiet clap at your own space. And my apologies that we have run out a bit ahead of a bit beyond time, 7 minutes. So thank you, Lorenz, Alberto, and Qiushi, and I'll see you at the next session at 4 p.m. Bye bye everyone. Thank you.